So I'm going to talk about architectures for mobile first. So mobile first is this whole new concept that every company talks about, how they have to transform themselves to be like mobile first. So what does that even actually mean at the architecture level? So why am I talking about this? So I'm a really former old school mobile engineer. I used to work at Nokia, the big R&D center they had. We did tons of stuff on how to optimize data for mobile phones even before we had things called smartphones. Like a crazy time. So I've been working mobile since the 90s, and it's been quite a ride. So today I'm work at a company called Realm, and we create an all new modern database for mobile devices. And because of that, I'm of course very biased, which you will see through this talk, that you really should use the mobile device as much as possible. So that's the primary message of what I'm going to tell you about here. So everybody's talking about how mobile is the thing now. Everything is driven by mobile. Mobile development should drive your whole company. But the big problem we have is that mobile apps are still being built exactly how we built web apps in the 90s. And you say, what does that even mean? It means that if you look at how things were with the web app 9, this is actually an image from the 90s, where you have some person who sits at a website and he does something and it sends a request back to a server, which sends you a reply back, and everything is this request response pattern. And of course, that's what you're used to. This do something, ping, get a response back. That's a well-known pattern. But the problem is mobile is not like that, and we're still treating mobile apps as if we're working with dumb clients. And that really sucks for the whole range of reasons. So why is this happening? Why are we doing development in such a stupid way? Well, the main reason is, first of all, this is how we've always done it. So, that's always the default answer to why people do stuff. So, you have, for the last decade plus, people have been building web apps. So, of course, they build up tons of habits of how do you do stuff. And the other thing, of course, is that in the process of doing that, a lot of backend infrastructure has been built, reflecting this way of doing things. So we have all these REST services, we have all this stuff out there that's really built on this whole request response way of building things. And there's actually also a real benefit to it. There's the fact that when you use this old pattern, then it gets relatively easy to make both a web app and a mobile app against the same backend. And that makes sense. That's a really good benefit. Of course, the big problem is that a lot of companies are not even mobile first anymore. If you go to Asia, most companies, they start to be mobile only. They just drop the web. It doesn't really matter anymore. But you can still say, okay, but that's a real benefit. And also the fact that people know how to do it, the fact that you already have APIs, those are all good things. It's actually real valuable benefits. So why shouldn't we just keep doing this? And the problem is that it does have some drawbacks. So the main drawbacks of doing this in a mobile world is, first of all, you get bad user experience. It's really hard to be tolerant about connectivity, because connectivity is one of these big differences from web. And then it's actually really expensive in server costs. So what does that really mean? Well, first of all, user experience. User experience is very different on mobile than it was on the web. There's actually been studies on this where they say the fact that you have a mobile device in your hand and you can actually touch it makes you feel that it's kind of like part of yourself. So you kind of feel like everything should respond instantly. Of course, there's really no tolerance for latency at all. The moment you have the small, you scroll and it does tick, tick, tick. It feels weird. It's like, why did it do that? And there's no excuse that, it just had to go out back to the server and get the next 10 pages. That just doesn't count as an excuse. And the other thing is, people's expectation of how much apps can do is just exploding. Again, if you have a web app, people are used to, okay, we went from like the old Windows application stuff, then we went to web apps, okay, things got very simple and everything was essentially forms. And now we're in a transition where everything is just, the complexity gets so much higher because this is a real app. And again, you touch it, you feel it, everything just moves around, you expect you can do anything. And you expect that it responds instantly to what you're doing. So the thing is, there's really no acceptance of any kind of latency or wait times. So this is both in the interface, that everything should be smooth, scrolling, the whole like 60 FPS movement, where you say everything should be 60 frames per second all the time. And the same thing, every time you press a button, it's not like a website where you press a button and you sit around and you're like, oh, now it came. On mobile, you press a button and it should be there. There shouldn't be any kind of wait times. And this is, of course, the problem. It's hard to build, to do for developers. It's hard to make that happen. And it gets like compounded by the next problem, which is connectivity, which again, a problem you never really had in the old web world. I mean, when you went to a website, I mean, even if, of course, if you go back far enough to the time when we had modems and stuff, you would have bad connectivity. But otherwise, connectivity is pretty much a solved problem on the web because you're connected and you have Wi-Fi or whatever. And it basically just works. And then you go to a mobile device and it doesn't. I mean, the fact is, connectivity still sucks. Pretty much everywhere. I mean, I don't know. I live in San Francisco and it should be like the center of Silicon Valley. And you can try to take the BART and you'll be like, half the time you won't have any connectivity at all. It just sucks. And I mean, you go out to anywhere here in the States, you go out into the countryside and I mean, there's hardly any connectivity. And it's really amazing. And then, of course, everything when you actually really need your apps, the moment you have any kind of crisis happening, anything, the first thing that goes down, or if you just had a big concert with a lot of people, I mean, everything just goes down right away. A conference, for that sake. So connectivity is one of these like really fundamental differences between mobile and the web, that connectivity is, sometimes it's weak, sometimes spotty, sometimes not there at all. And the funny thing is, people still expect your app to work. Of course. I mean, it's in their hand. They don't feel that this is a browser, a web browser. This is something they have in their pocket. And this, I mean, and it's hard for everybody. I mean, even for big companies like Google. I mean, this is actually a screenshot from Gmail. That the moment you lose connectivity, suddenly you can't search at all. You can't access any of your old mails. And you're like, what does that mean? Why? I mean, I could do that on my old PC like 20 years ago. I could have all my mails, and this one has like 10 times the storage. What's going on? And it's actually really a problem. I actually had this, last time I went to a conference, I actually came and I didn't have any connectivity. And I was like, oh, where's the conference? I was like, that's in a mail and it's like a bit too old to be in the cache. Too bad. And you kind of expect that you have it on you, but the moment connectivity runs, you don't. And that's just because this is built against an old, Gmail clients built against an old REST API from running their own Gmail service, web app. And it's just built on this old pattern. And it's annoying. And the other factor, of course, is if you're building apps today and you say, okay, where's the next big market? That's in developing countries. And that's a whole different game than here. First of all, they have even worse connectivity. Obviously, that kind of sucks. And also, they have very high data prices. So that means that their data plans are really, really expensive. So they can't just get ping back from data back and forth all the time. Things have to be effective on the device. And the last thing on this, which is pretty much the same as with the web, is that running a modern app, again, because of the expectations that people have today, is really expensive server-wise. Because, for better or worse, people have been conditioned to the fact that everything is instant. So if you ever see a search bar in your application, you expect that when you start pressing this, that of course it starts auto-completing and showing results while you're searching. Obvious. That's just what you're used to. That's like Google, right? The problem with that, of course, is that means that every single user out there, every single time they press a single button, you have to go back to your server and do queries and whatever, which all cost money. And especially now, I mean, I'm from San Francisco, there's tons of startups. And when you're a startup, you know that you have this kind of problem where most startups, they need a few million users to actually get off the ground, which means that you have this kind of problem where your cost goes up like this at the same rate as your users, and you kind of hope that you take off, either you raise money or you get profitable before you hit the peak and you dive, because when you run out of money, you die. Right? So that's really a problem. And for anybody who's tried hosting their apps on Amazon, you know that Amazon actually is really, really expensive. So what is the fundamental problem with this like cache approach, which is kind of like the way you do with a web app, where you don't really own the data. You're just like a thin client, kind of like showing everything essentially like a web page. And of course, the problem first of all comes with every object you have in your data. I mean, essentially you work with objects most of the time. If you have an object, as long as it's in the cache, everything is fine. That's what we saw with Gmail. Gmail has like the last 20 mails or so in the cache. As long as you look at them, everything is perfect. Of course, the problem comes when you have to access a mail that's not in the cache. That will either be a bit slow, just the latency of getting it, which is okay most of the time, or it won't be available because the connectivity is not good enough. And that kind of sucks. The other thing, of course, is that if you do an app that's just a little bit more advanced and you need to do queries, that could be, again, in like an app, like an email app, where you do a query for your mails, of course. But it could also be most modern apps do tons of queries internally as well, just to show the right information. Suddenly you're in this situation that will be slow because every query you do has to go back to the server. And also, again, the whole thing, the moment you have no connectivity, everything that needs to do queries in your app essentially grinds to a halt. Because the fundamental fact is you can't do a query on data you don't have. And if you only have a subset of the data cached, well, you can't really do a query and expect to get a correct result. So that kind of sucks. The other factor that's very big is that when you have this kind of thing where you have a backend with the REST API, what you see is that the mobile team suddenly gets very constrained in what they can do. Because every time they say, hey, we actually need a new kind of query, a new kind of data type, anything, they have to talk with the backend team who has to implement it, who has to make sure that the REST API has the right commands, that they give it back in the right format. And there's a lot of work actually being done now to try to get around that. I mean, if you follow the more in the web space, but also with also mobile, you see guys like Facebook trying to do Relay and Netflix trying to do Falcor and all the things to try to see if they can decouple a bit so that the front-end guys can actually keep working even though they don't really know what they need from the back-end yet, which is a huge problem. So in general, with this approach, it's really hard for the mobile team to move as fast as you would like to be. Because again, this world, there's so much competition, you just have to be able to iterate really, really fast. And that's just really, really hard. So the big question, of course, here, what is the solution for this? I mean, what can we do to give the users a better experience, handle all these connectivity issues, and reduce the server cost? And the solution that's starting to grow up now is something called endpoint processing, endpoint computing. And the idea here is to say, well, mobile devices have changed. Again, back when I started, a mobile device was really, really weak. It could hardly do anything, and everything was constrained. But today, it's crazy what you can do in a mobile device. I mean, a modern mobile phone is more powerful than a rack server was just a few years ago. It's pretty crazy. And we're hardly using that. So the idea of endpoint computing is to say, well, essentially, if you're an app builder or a company that builds app or anything, you actually have access to a gigantic cloud of massive power of all these users' devices. And it's free power, because they are the one who paid for it, the users. They pay for the energy, they pay for the phone taxes, they pay everything. So essentially, you have the ability to, if you can use that, if you can offload the work to the user's device, you can offload tons of both cost for yourself and you can give the users much better experience. So essentially, you just have to use it. So the idea is that you can actually use the phone as the primary store. Keep all your data on the device, work with it directly, then it's always available, everything is always instant. There's also a lot of things actually you can do around like stuff like compliance, if you're doing health apps and stuff, HIPAA compliance and things, by having the stuff on the device owned by the user. And in this case, you can also take your backend, essentially gets relegated to be coordination of everything so that you can share this between all the devices, backup and statistics and all these basic things. But that's hardly any work. Your backend becomes much, much cheaper. So fundamentally, this is how things used to look, or still looks a lot, where you have the cloud, where you have your data and you have all your business logic, everything happening. And then you have the mobile phone, which just has a small cache and a UI layer. And the transition we're starting to see, we see this a lot, of course, since we create mobile database. We talk with tons and tons of companies that build mobile apps now, a lot of the big companies doing mobile apps. And we see this transition happening where more and more of the smarts get put into the phone. So instead of having all this logic in the backend, just move it out to the phone, because that means that the mobile team can just work on their own. They don't have to talk with anybody else. They don't have to coordinate with a big backend team. They just build whatever they need to build and iterate as fast as they have to do. And again, there's no latency. There's no overhead and having to go back and talk with the server back and forth all the time. But of course, this is something that some apps are really good with and some apps are not as amenable to do. So you can say, where does this work? Well, if you look from the, kind of like with the data classes on, there really only exists 3 kinds of apps. There's the single user apps, there's collaborative apps, and then there's the kind of what we call a browser app. Not in the web browser sense, but in the data browsing sense. So a single user app is essentially an app where the user owns all the data in the app. So there's tons and tons of these. I mean, an example was like Mint, of course, every bank app where you have all your bank data. There's lots of note-taking apps where you just do your own notes. Of course, every email app, it's like your emails you have, Expensify. So everything where you can say, well, this is only about my data. And those are obvious apps to do this kind of endpoint processing on, because you can just keep all the user's data on his device. Of course, you still want to have it backed up on the back end because he can lose his device any day. But he can essentially have all of it, and all the logic can be on the device. And it's extremely powerful in that way. But that's, of course, not the only. I mean, this is a huge portion of the apps, but not all of them. Then there's kind of what you call the collaborative apps. There's kind of like 2 aspects to that. Collaborative in the sense that it's not only your data, it actually also contains other people's data. And a lot of them, you see, I know a lot of people probably use Slack, that's an obvious thing. All kind of chat apps like this. I mean, you have your own messages and you have other people's messages, and they kind of go in and out. And you have stuff like Facebook and Twitter, which is kind of like the same in different ways. So that's one way of doing collaborative. Then, of course, there's what you could call like live collaborative, where not only do you get other people's data, but you're allowed to edit it, and it's like live edits that you see each other's changes, which is much harder to do. And those are in general also really good for this. Not always, but in general, because there'll usually always be like a subset that's kind of like yours. For example, if you're Facebook, your timeline, that's yours. It might be composed out of a lot of other people's data, but you have your own timeline. That's the one you search in. If you search, that's what you also can scroll in. You can keep all that on your device. The same with your own Twitter stream, with Slack, all the channels you're in. It's a natural way to build it up. So that's all stuff that can be local as well on the device. And some others that are it gets more amorphous. And then there's the last one where it's kind of like browser apps. So these are the apps where it's not really your data, you're looking at other people's data. So the obvious one is like YouTube, the YouTube app. I mean, it's not your videos, you just browse around and look at different people's videos. Also stuff like Tinder, where you look at other people's profiles. There's tons of these kinds of apps as well. And these apps are not a really good choice for this. I mean, there's really not much work. I mean, you really don't want to keep all the YouTube videos on your device. That would suck. Really bad. And again, Tinder, most of this, you can do a bit of caching, like maybe some pre-caching, maybe stuff. But you really don't want to do what you call like endpoint computing with that. Even though there's a little bit of thing where you can say that there's usually a lot of metadata you track. I know we work with a lot of companies where they track a lot of statistics and do a lot of measurement on the users and things. And that's all stuff that's good to track on the device. But that's usually minimal. So these kind of models can usually be mixed together. So what would I say to do mobile-driven design? So the first thing that is, it's kind of a change of mindset, where a lot of apps are kind of built in the sense that you have a backend API, and then you say, okay, how do I build a mobile app on this? Where the whole idea of mobile first or mobile-driven design is you start with the app and say, how can I make the absolute best experience for the user? And what is the ultimate app? How would users want this to be? Then you build that, and then the backend kind of has to follow. You just have to do essentially whatever it takes to make that app work. And that's quite a mind shift change for a lot of developers. Because again, they're used to working against standard REST APIs. They're used to this kind of standard way of working. And having this say, okay, what is the ultimate experience? Because if somebody had started to build an email app, just starting with the app, and then they said, oh, do people actually want to be able to search in their data, even when they're offline? Well, they probably do. And if they say, okay, do people actually want to like click on an email and have to wait until it comes up? They probably don't. This is all constraints that came from the backend service because they started from that end. If you start from the mobile and say, okay, what is the experience? That will drive the whole design. So you can see how does that affect your backend? I mean, your backend API. For many problems, it doesn't really change it that much. I mean, if you have something that's mainly like a one-way API, I mean, essentially you just ask what's changed since last time. And that's a lot of them. If you're like Facebook, you can do some changes yourself, but you're actually not that much you write. Mostly you read other people's stuff. So mostly you just do like some kind of request back and say, hey, give me everything that changed since I last looked. That's a simple API. Then you can just pull that on the device and store it for pretty much forever if you want, so you can access that. The big problem, of course, comes when you want kind of like two-way synchronization, where you actually say, hey, I'm actually changing this, and I kind of expect that the other people I'm collaborating with, they see the changes as I do them, and I see theirs. And the funny thing is today, if you look at like collaboration, everybody's collaborating, because most of the time you're collaborating with yourself. Because you have all these different devices. You have like your iPhone, your iPad, your whatever, tablet, your iWatch, and your laptop. And of course you expect that they are all the same. I mean, from a mental perspective, this is all one computer. All these different devices. So when you change something on one, you of course expect that you see that instantly on the other ones, because it's your computer. I mean, it's kind of bring the whole, if people can remember back in time that Sun had this idea, the network is a computer. And it's kind of changed around that now. All your computers are your computer. And that's actually one of the things that's really, really challenging for developers to build today. There's really no really good solutions. Most of the kind of synchronization solutions you'll find out there breaks down really bad the moment you have bad connectivity. So this is actually kind of like how call for action. We really need much better tools and backends and stuff to handle synchronization for life, because that is what you expect. You expect all your devices to be one computer, and you expect to be able to share parts of that with other people. And it just comes natural from the kind of devices we have today. So of course, again, is this always the right choice to go for this kind of processing? It's primarily for apps that are user-centric. If it's any kind of user-centric, you really want to keep all the user's data on the device, so it just works. If you just browse other people's data, and you're browsing, which means that like the old web browser model probably fits pretty well. It's kind of inherent in what you're doing. But what are the benefits? I mean, just to summarize. So the benefits of doing things on the device is that you get much more responsive apps. Again, the latency has this annoying thing that there's kind of like a limit, like the speed of light is, you can't really change that. So no matter how much you optimize things, you can never get faster than that. And then when the moment you go mobile, you also have all the like cellular communication latency, so it gets even worse. So if you want to responsive apps, you can't wait for data to come. You need to get it before the user asks for it. And then, of course, the whole idea that, I mean, it just has to work with, no matter how the connectivity is. I mean, connectivity is always spotty. I mean, it goes on and off, like depending on where you are, how you move. And it should just keep working. This should be hidden from the user. They shouldn't have any experience of this. And then, of course, you really want to reduce the server load. I mean, it's just a huge, and both things, it's not only the expense, it's also, I mean, you just heard how much work it is to manage a distributed database, how problematic it is to handle like big data. And there's no reason for that. If you can have, like, we actually have users out there who have 100 million of users. And they hardly need a backend, because it's all on users' devices. It's naturally distributed. And that is a really unique situation. You can run with 100 million of users, and you can have like a backend that's hardly anything. It just like coordinates things and does a bit of backup here and there. That's really an amazing thing. It's a huge, huge reduction in cost and complexity. And again, it means that your mobile team can just move ahead really, really fast. They don't have to coordinate with anybody. It's just go ahead, build whatever they want, total freedom on the device. And again, a lot of the complexity, again, if you heard some other talks here, where when you build stuff and you have like a component that needs some data and it has to do a REST request back to a service to get it, if you have everything local on the device and it just gets updated by a background thread, development gets so much easier because you're just working with local data structures. I mean, that's something that every developer can do. You don't have to like think like how to do this asynchronously, how do I send this request, how do I like wait, when do I get a response back, if I even get one back, and how do I update things. There's so many steps you have to get through to get that to work. That all adds complexity and bugs and stuff. Where the moment you have all the data local, easy peasy. I mean, you just code like normally. And this is not only for mobile devices. So this is this demand of things being fast and local. That's really what you see coming up in all the new stuff that's coming up at the moment. So of course, live collaboration is a really big one happening all the time. I mean, if you see, it's kind of like the expectation everybody grows up with with mobile devices. If you have kids, you'll see them play Minecraft, and you see that it's a social thing. They sit together and play next to each other. And you start to see the same with business apps, where when you sit and go to a conference room, you see people at a conference table, they sit working together. Google Docs, whatever, they sit and work. So all apps are starting to become collaborative. And pretty much every developer who's built it has to start from zero and invent their own solutions, which is not really like a really good way of doing things. And then, of course, we have the whole Internet of Things. I mean, it's a really exciting time to be involved in data as a general, because like the best estimate says that within the next 5 years, like 80% of the world's data will come from mobile devices. And that includes all what we call Internet of Things, because the definition of Internet of Things is devices that capture data. And so it's just really, really interesting to work with this. And these have a huge, huge amount. The idea of endpoint computing came from the Internet of Things. Because when you have all these Internet of Things, these sensors and stuff, you want to be able to capture the data there. You want to be able to pre-process it. You actually want to be able to do machine learning on it, just like classify it and do stuff before. So you only send the stuff home that actually is interesting. So everything is about how do you work on the endpoint with the data. So you only send the actual signals home that are valuable, because otherwise you just drown. And you have no way of handling all this. And then we have interesting stuff like virtual reality. I mean, if any of you have worked with virtual reality, you see the biggest problem with virtual reality is that if you can't get the feel like 60 frames per second, people get sick. They literally get seasick. And again, as you can see, that doesn't really leave much space for latency for getting data over the network. It's really, really hard. I mean, if you have to wait like 200 milliseconds to get something from over the network before you can draw the thing that people just came to look at, that's gonna suck. So again, you have all the thing like data locality really matters. I mean, it's kind of like how it used to with big data, that you want to bring the computation to the data. And it's the exact same thing with mobile devices. You really want to have the data and computation together so you can remove all the layers of latency. And we have the same with variables, of course, and drones are the same. They go out there, they capture data, and they have extremely spotty connectivity. Usually they have to go home and then they won't be able to like give it off before they come back. So this is essentially why, say like endpoint computing is also called client cloud computing. It's kind of like, I think Gartner is saying this is one of the big trends coming up. I think if you saw Andreessen Horowitz, they had this like 60 things that are most interesting for us in the future. And then like one of them was, again, client cloud computing, as they say, like how do you harness this massive power of all these devices out there, which are pretty much idling most of the time right now. We use like a millifraction of what our mobile devices are capable of. So that was pretty much me. So do you have any questions?